Hello, welcome to this video, and what we're doing today is using the Raspberry Pi Sense Hat. I'm going to give you a tour of everything that's on the Sense Hat, and then I'm going to be showing you a few bits of example code for it. This is a fantastic thing to have for the Raspberry Pi, and if you don't know much about it, I'm going to explain it in more detail now about what exactly it is. Hope you like that little clear code thing, but I just wanted to get the blue stuff off the screen so I could actually explain this. Right, you might not have heard of this, but if you're a Raspberry Pi enthusiast you might have done. It's called AstroPi, and we made this shield for the Raspberry Pi and we took it up into space on a Raspberry Pi. It had a really nice enclosure on it and stuff. It wasn't just the Raspberry Pi and the hat. And we did 7 experiments with it, and the experiments were designed and programmed on the Raspberry Pi by students across the country, and it was really exciting to see what the different results were, and they were done in very creative ways. Like one of them even used Minecraft in order to map out certain things in space. And what the Sense Hat allows you to do is take what they used home. This is pretty much what they used for bare bones of it, and it's a little hat for Raspberry Pi, or a shield as you might call it. It's got an 8x8 dot matrix display that can display different colours. You know, we've looked at some of the things it can do. Display text, images, all sorts. You've also got a little joystick. You've got, I'll zoom in a little bit more. Hopefully the camera will focus. You've got an accelerometer here. It's also a gyroscope and a magnetometer. You've got a pressure sensor, a humidity sensor, and a few more things as well. It's very, very cool. What I thought I'd do is explain each of the things that are on it. Okay. First of all, let's have a little look at what a gyroscope is. A gyroscope, basically, the gyroscope on here is part of the accelerometer and magnetometer, this thing here. What a gyroscope is it, what it does is it measures the orientation of an object. You've got the pitch axis, which is up and down, a bit like a plane taking off. The yaw axis, which is left and right, like steering a car. And roll axis, like a corkscrew movement, barrel rolling a fighter jet. So it's got 3 axes and it can detect the orientation of an object. We've got the accelerometer, which is part of the same thing there. An accelerometer just measures an object's increase of speed and acceleration. And at rest, it'll measure the direction and force of gravity, but in motion, it measures the direction and force of the acceleration acting on it. It can also kind of it can detect where you are from where you started, where it's moved. You've got the magnetometer. All it does there is it's used to measure the strength and direction of a magnetic field. You've got a temperature sensor that just measures how hot or cold it is, just like a thermometer. Barometric pressure sensor, which is there. What that does is it measures the force exerted by tiny molecules of air we breathe. Basically the pressure. And it has a pressure sensor built in, and it will report air pressure to you in millibars in your code. Humidity sensor, which is, there's a humidity sensor. That one there, very small. Humidity sensor measures the amount of water vapour in the air, the humidity. Then you've got the 8x8 LED matrix display. This is the only real form of visual output that the AstroPi's had on the ISS, because we weren't allowed to use HDMI ports, obviously, or composite outputs of the Raspberry Pi to anything. So we did have to build some sort of display so that Timpy could be able to have some sort of visual element of it. If you couldn't use a monitor or anything, you'd have to have something like this. And also a mini 5-button joystick if you wanted to program games on it. That's just a very little tour of the different things that this can do. And what I'm going to do now is show you a few examples of some code on it so you can see just how it works. I've already shown you one example of code on it, which is the text scroll example. By the way, you need to install a library for it. Just Google it, you'll be able to find it, or there's a specific line that you need to enter for it, but just make sure you've got the library installed before you move on. I did show you the text scroll example before, and I'll show it you again now. It just does / clear code, except from that is upside down. Obviously the example didn't have my name on it, well, my YouTube name. We're just going to have a quick look at now what the code is behind it. This line's just a comment, so ignore that. From SenseHat import SenseHat, so we're importing the library so that we can actually use this SenseHat. We're making a variable for it, sense equals SenseHat, so that we can just say sense.set sense.show message. We need to set the rotation of it to 180, and then here we're making a variable for the colour red. It won't recognise it if we just put red, so we need to say what red is. And this is RGB, the amount of red, blue and green. But because we just want red, we put the other two as 0 and put this one as 255. And then we use the command sense.showMessage, and then I've just changed it here to clear code, but you can put any message in. So I'll change the message to change the message to something else so that you can see it works. I'll change it to AstroPi. Save it. And then sudo python text scroll .py. Press enter. AstroPi. There we go. Let's take a look at another example now. This example is... Hold on, I need to find it. Colour cycle. Let's first of all have a look at what it does. You can see here that it's changing colour and it's going through all the different colours that this can display. I can see it's not coming out very well on there, but it's just displaying all the different colours. Alright then, let's have a look at the code behind that. Here we have the code for it. In the SenseHat examples, it's called Python SenseHat. First two lines, the same as before, importing the timeline. Maybe not the same as before, I don't think we have the time. But import the time library and import the SenseHat library. We create a variable for SenseHat, and then we make 3 variables for R, G and B, red, green and blue, which we'll use a lot later on. We start off with red being at 255, presumably because we start off at red and then we go to different colours. Here we've got a function for next colour. And with global R, global G, global B, we're just saying that they're global variables, so they can be used throughout the whole programme. If red equals 255 and green is less than 255 and B equals 0, green plus equals 1. You've got loads of ones like that going all the way down. Well, loads of lines down. But what we do is we just make, once it's hit a certain level of, once it's a certain colour, it just changes it to go to a different colour. So it goes through the whole colour cycle. And then here, while true, sense.clear RGB, M sleep 2, and next colour. And next colour is is defined here. That's what this code does, and you've seen what it does. It just goes through the entire colour cycle. Now I'm going to show you how to change the individual pixels with this code here. First line, just importing the sense.out library, making a variable for it on the second line, and then here we've got something called sense.setPixel, and it's just to change a single pixel. If you look at the Raspberry Pi from this way, the LED dot matrix is labelled and it goes like 1, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, like that. Here we're going to change the pixel into 0, 2 and 7, 4. At first one blue and next one red. Let's just run this program now. Sudo hyphen pixel.py. And let's have a look. Now, I don't know if you'll be able to see this brilliantly well, but this one has changed to blue and this one has changed to red, but because the other one's running, you can't see it brilliantly well. That's how to change an individual pixel. Now that we know how to do individual pixels, set certain individual pixels as certain colours, we can actually do a whole image just from changing colours of pixels. Here we're specifying what each of the colours are, like red, orange, yellow, green, blue, indigo, violet, and whatever E means. That's probably 000, probably black. So this is RGB, red, green, blue. Before, first one here, red, then green, then blue. And we're just saying what each of these colours would be, how much green it'd have, how much blue it'd have, how much red it'd have. And we're saying here image, and then we're just having, this is an array, and it's just all the colours that we're going to have on the image, and then sense.setPixels image. Let's just see what this does now, because this will be quite interesting. So right, sudo hyphen pixel.py, and here it's made an image. So that shows how you can make images, your own images, with the Raspberry Pi without having to do hundreds of lines of code. As well as the Raspberry Pi Sense.out having a great LED dot matrix, it's also got loads of great sensors and stuff like that. So, this bit of code here utilises the following functions of sense.getTemperature, sense.getPressure, sense.humidity. It's going to use loads of the sensors on board that we've had a look at, as well as the screen. Let's run this. Sudo hyphen sensors.py. Right, I'm going to have to run this again because it's going extremely quickly. Just hold on a second. Like, it's very hard to read because that's what it's doing. I'll just run it again so that you can see the whole thing. Temperature equals 32.6. Pressure, oh, I'm not sure what that said. Humidity is 39.4. Yeah, this is already ran once. This is just going to go over and over again and tell us the temperature, the pressure and the humidity on the dot matrix screen. For the final bit of code I want to test out on the SenseApp today, it's going to use the accelerometer on board, and it's going to print on the dot matrix display where it is in relation to where it started. Let's just save this code, take a little look at it. Sudo python accelerometer.py. On this, oh no, it's not going to do it on the dot matrix display, it's doing it on here. When I move this around, it's hard to move it very far along because it's connected by cables. But when I move it around, it's going changes. You've seen the y-axis change. Yeah, it's very difficult to move it around very far. Here we go. Z-axis is moved by 1. Y-axis. You can see that it's changing, but not very much. And there we have it. This is the SenseApp. Fantastic hat for the Raspberry Pi, and I highly recommend getting it if you're into like Raspberry Pi and doing electronics with it. And I will be doing more videos on it, and I'll do a few projects with it that are more advanced than this, but this was just kind of showing you how to get started with it and doing some very, very basic things with it. That's all for now. Thanks for watching, and I'll see you soon with more Raspberry Pi, Arduino, all sorts of videos like that. See ya!